Yet another disco light, and don't worry, it's not going to be solid disco lights from now on. This is just a small batch of lights I bought together just to compare them, and this was the cheapest and smallest of the lot. It's mains powered, and it has the red, green, blue LED, and it's the same reciprocating circuit board arrangement, but this one only does two things. It has an audio sensor. If it's not detecting audio at fairly high levels, it will just cycle through the colours, and it's a very simple sequence. It goes red, red, green, 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 blue, 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 red, and red, green, and blue. And it just repeats that cycle, so 7 steps. But if it detects audio, it will pulse those colours and then step on to the next set. And it will respond to modest speeds. If I tap it, so that's about the maximum speed it's actually going to respond to before the point it just rolls over onto the next beat. So let's take a look inside this. So I'll make sure it's unplugged first. I've already taken the screws out of this. It's quite an interesting construction in the sense that they've got the strain relief is just basically a cable tie, and then this goes through a channel on the side. And the case has a couple of indents. One is designed to either grip the cable or actually, it looks as though it's got an indent to block one side and just basically just gently grip the cable at the other side. Simple. It's got the same arrangement the other one has of a loose circuit board just riding on a cam on the motor. Oh, look at that, I can actually power it just from rotating the motor, that's nice. I wouldn't say it's happy about it, but it is powering it. The circuit board is notable for the fact that it's got extra connections and the facility for the infrared receiver built onto the moving circuit board, which is odd. So let's take a look at the power supply here. Let's get the snips into this. So let's just unplug that. We shall get the screwdriver to get that off. Or actually I could just like pull the plug off, that would be really sensible. And the circuit board then just slides out. So how's that normally held in? It must be held in just by the lip at the end here. Oh, and this lip at the side probably. Oh, does it? What holds that in? I'm going to have to just pop that back in and take a look. That's intriguing. Ooh, this is a worm. Oh, it's the resistors. So where was that arranged before? Was it? I can't remember which way around that went. Oh, it's all gone wrong already. Yeah, see, I've screwed up already, but I should have actually done a bit of rehearsal on this, but I never rehearse anything, so right, that's more or less it. That'll do. Oh, I've screwed this up so much so far. Well, I'll just go into what's on the circuit board. So what holds this in? Does anything hold it in? Does luck hold it in? It might actually just be the cable tie on the mains lead. It is. I think it is the cable tie on the mains lead just holds that down. I don't see anything really obvious other than that. I don't think that lip doesn't protrude in far enough, I don't think, to actually hold that in. Oh, that's a bit crappy. Not to worry. So we've got two outlets here. Jack 1, Jack 2, are they? One of them is 3-pin. I'm guessing that might be the infrared receiver. Could be implemented. The circuit board itself has the mains come in. It's got a bridge rectifier. I'll just put my finger across the electrolytic capacitor to make sure it's discharged. Yes, it is. Mains comes in. It goes through this makeshift fuse of zigzaggy tracks, which will just blow up and make a mess if it fails, but I suppose it's better than nothing. It goes to a bridge rectifier, and then the electrolytic 4.7 megafarad, 400 volts. It's a Chung X again. Interesting switch mode chip because the number on it, it's an unusual package. LP 50, and then it says underneath 30B6N. Not sure what that is. It's unusual because it's a gullwing type package. surface mount package, but it's got two big wings at one side and three small ones at the other. It's an interesting arrangement. And the rest of the components around it are more or less what you'd expect of the filtering for the to protect the chip from the transistor on the chip from the switching spikes from the transformer, and then just some basic feedback circuitry. But I don't see any feedback from the other side. It might just be rough current. It might just be a very simple sort of 5-volt type power supply. Uh, that would make sense because I didn't measure it. That would make sense though if it was based on producing 5 volts, sort of in the style of a USB power supply. The 8-pin chip, the ubiquitous 8-pin chip down here has no numbers on it, but we can guess it's a microcontroller. I do see a couple of transistors associated with that for the audio filtering from the microphone. And then I see 3 switching transistors and a cluster of resistors to the LEDs themselves. And that's more or less it. Now, one of the notable things here is that there's 2 capacitors. I think that might be a layer of filtering to avoid the switching noise getting across to interfere with the microphone, the audio circuitry, because there's the diode from the flyback and there's its capacitor. And I'm guessing that is just maybe decoupled, this capacitor here, to provide that slight element of filtering. The separation, you can see they've made a kind of attempt at separation, kind of defeated by a pad right in the middle of it that has nothing connected to it, just a random solder pad plated through a hole right through where the separation should be. It's like, oh hi, we've not defeated the separation, let's add a pad there, right in the middle of the text as well. That's just bizarre. And that's fundamentally it. It's not that sophisticated. It's probably based on a USB power supply, microcontroller, little audio amplifier just to detect a threshold, and then it's switching the transistors to drive the LEDs on the circuit board, and the motor will just be running continually on a 5-volt supply just fed straight across to it. So very, very simple. Okay, this isn't necessarily an approved test procedure when you've got a mechanically gyrating 240-volt circuit board on your bench, but let's precariously poke around the probe and see if we can get the voltage. This will be reverse voltage probably, unless they get the polarity wrong again. Oh, they have got the polarity wrong again. That's just weird. So the voltage going to the motor is 4.6 volts, and I'm guessing that's coming from the power supply as well. So that makes sense. It's kind of floating up and down a bit, depending on the load. So that is pretty much a USB supply, but maybe optimized, just tweaked a little bit to put out a slightly lower voltage, because that way it reduces the dissipation from the resistors. It makes it a bit easier for the circuitry to drive the LEDs at a good intensity without getting too hot.